Hey guys, welcome to Power Mathematical Reasoning 23. We're just going to go through some questions and hopefully it'll broaden your understanding. Let's jump straight in. So question number 1. Peter likes salted cashew nuts. Okay, he likes them better than any other nut. His mother went to the nut shop and bought a bag of mixed nuts. In the bag, there were 40 pistachios, 35 cashews, 35 walnut halves, and 40 peanuts. If Peter takes one nut without looking, what is the probability that he will get cashews? Now, a reminder that all these different types of nuts are in one bag. So, our probability comes down, wrong pen. Our probability comes down to this. It's going to be equal to the object of interest over the total number of objects. Okay? Of objects. Now, the object of interest here is actually the number of pistachios. Oh no, not pistachios, cashews, isn't it? Which is 35, as it says here in the question. 35 cashews, and over the total number of objects. So that would be 40 pistachios plus 35 plus the 35 walnut halves plus the 40 peanuts. Now, that's going to be our probability, which is equal to 35 over 150 if you add that all up. Make sure that's 0. And now, we cancel the numerator and denominator by 5. So what I mean by cancel is, I noticed that the top number, the numerator, and the bottom number have a common multiple, common factor. And we choose the highest common factor so we can get the simplest form. Okay, what is the highest common factor, you ask? Well, it would be 5. So we divide top and bottom by 5. Remember, in a fraction, we do the same thing to the top as we do to the bottom, and vice versa. So 35 divided by 5 is 7 over 150 divided by 5, which is 30. And then we get our answer B. So, give that a circle. Next, Maria has 4 children. One is a teenager, 13 to 19 years old, and the product of all their ages is 15,680. The eldest of the 4, okay, is 20, and the youngest is 7. How old is the teenager? Right. So straight away, we realize that we don't have the second oldest and third oldest, okay? We don't know this, okay? So how do we find the rest out? Well, we work, as always, with the information that is given. So let's lay out the information we're given. 20 times 7 times the second oldest. I'm just going to call that the teenager T, and the third oldest as let's say third. Actually, let's not use numbers there. Let's use that as the C. Okay, because C is the third letter in the alphabet. It doesn't really matter. But anyways, I'm going to say that 20 times 7 times T times C, which is all the ages of all the siblings multiplied together, is how much? 15,680. Okay? Well, then we know what T times C is. Because T times C times 140, because 20 times 7 is 140, is 15,680. Then T times C must be equal to 15,680 divided by 140. Now, how do I get from this step, the second step, to the third step? Well, imagine I divide each side by 140. Okay? 140 divided by 140 is 1. So that's just 1 times T times C, which is what I have here on the left side. And on the right side, we retain this 15,680 divided by 140. So now let's figure this out. Do this together. Divided by 140. It goes into 156 once. So 140. And then remaining 16. Carry the 8 down, and that goes into that once, 140 again, then 28. We carry the 0 down, then 140 goes into 280 2 times. Right, so we've arrived at the fact that t times c is actually 112. Well, that's great news. You might ask why. It's great news because there's only one couple that can multiply to create 112 if one of those numbers is between 13 to 19 years old. So if you ever wondered why the question ever specified that the teenager is between 13 to 19, well, this is the reason why. Because there can only be one pair, and our job now is to find that pair. And this you do by trial and error. So let's try 13 first. Let's say the teenager is 13. So this is hypothetical trial and error. I'm going to label it T and E because trial and error. Okay, so let's see. What times what? 13 times is 112. We realize that that other number is not a whole number. So we cross that out. We say, nope, we can't deal with that. Then let's try the next biggest number, 14. Let's see if this works. 14 times something equals to 112. Now, if the teenager is 14, then the question mark has to be actually equal to 8 if you do the calculation. So we've already found our pair just like that in the first 2 goes. So what do we have? Teenager. So we write by trial and error. Um, 14 by 8 equals to 112. And therefore, let me rub this side out, since you guys know what we did. And therefore, teenager is 14 years old. Okay, that'll be the perfect working out. So if she is 14 years old, the answer has to be then D. Okay? Hopefully that makes sense. Let's go on to the third question. Now, this question is actually pretty difficult in the sense that, yes, we know how to find the area of a triangle, but that's not all we need, right? We need more. What do I mean by that? Well, we need a tactic for this question. Because if we're trying to find the triangle area of ACD, which is actually this triangle here, ACD, okay? If we're trying to find the area in between here, we realize that we don't have heights, okay? We don't have height. Well, we do have height in the triangle itself, which is this. We can't actually calculate it because the boxes are not properly matched. Let me get rid of the red to show you guys that the boxes for the height, which should normally be this, okay? Remember the height is perpendicular. The height, we don't know. And if you're asking, why do we need to know the height? Well, to find the area of a triangle, okay? A triangle is half times base times height, okay? So sure, yes, we know what the base is from C to D. That's the base, right? Oh, that's not the base. Sorry, guys. The base is here, A to C, okay? We know the base. We can count that. Actually, no, we can't even count that. We can't even count base. I just realized we can't even count base or height because look at this. It's not it's not even matched to the corners. So we can't count that by hand. So unless the question tells us, we have no idea of telling what the base is or what the height is. So immediately we have to get rid of the idea of calculating the area of the triangle straight away. Okay? And after we've done that, then the next question pops up. Well, how do we find the triangle ACD? Your next automated response should be, it must be a result of subtracting one bigger triangle area from a smaller triangle area to create that area ACD. And what do I mean by that? Well, let's have a look. First, we find a triangle that we can find the height of. Okay? Namely, triangle ACE. Okay? Next, we find another smaller triangle that when subtracted from the bigger triangle will give us the area of ACD. And these two triangles that I've highlighted thus far are actually the triangles we're looking for. So, what do I mean by that? If I subtract this whole red section by this yellow section, can you guys see that what we're left with is actually this section? Can you guys see that? And that section is actually the area of triangle ACD. So, what do I want to do? Well, let's lay it out like this. Area, so I'm going to denote that by capital A, of triangle ACD equals to area of the bigger triangle. What was the bigger triangle? ACE. Okay? Area of triangle ACE minus area of the smaller triangle. What was the small triangle in yellow? ADE. Okay? Triangle ADE. So once we do that, then we'll get the area of ACD. Hopefully that makes sense so far. And now, let's have a look. Once we've done that, we just need to find the numbers. What is area of triangle ACE? Well, what's the base, first of all? ACE, we have the base. If you count it, we have a base of 8. And what's the height? Well, we can find the height by counting the number of squares here. And if you've done that, we can find that the height is 9. So according to the formula, area of triangle is half times base, which is 8, times height, which is 9. Okay? And now we subtract from the area of triangle ADE, which is the yellow. Let's find the base for that. Alright, base for ADE. We have 3. This base is 3. What's the height? Height is the same, 9. So we say half times base, 3 times 9. Okay? And now all we have to do left is calculate this. Okay? So 8 times 9 is 72, times half is 36, minus half times 3 times 9. What's that? That's actually 13.5. And so our answer is, or should be, 22.5 centimeters squared. But we actually have an issue here. If you guys notice, none of these answers state 22.5 centimeters. Okay? Meaning that we've done one thing wrong. One assumption that we've assumed that we shouldn't have when we have these sort of unit questions. If you guessed that it was the assumption that each of these cubes have an area of 1 centimeter squared, you're right. Okay? We've accidentally assumed that the side length of one of these cubes is 1 centimeter. When in reality, the question never stated, okay, one side of cube is 1 centimeter. Meaning that our units are different from what the actual units are. Okay? So let's have a find out. Here we come to the first line of the question. Triangle ABF is 18 squared centimeters. Now we actually have a use for this statement. At first you might have thought, oh, they're just trying to trick me. It's irrelevant. But in fact, it is relevant. Okay? Whenever you guys see that these sort of questions where there's units involved, but it never states how much one of those units are, you always have to question whether what you're calculating is really what you need. So, if triangle ABF, which, let me get rid of these. Triangle ABF refers to this triangle over here, ABF, okay? That triangle there. That triangle is supposedly 18 centimeters. So we check it. We're doubting now. what's the base? What's half area of triangle ABF is half times, what's the base? 15 times. You guys can have a count in your spare time. The height is actually 9 as well here. Guys, by the way, the height's talking about this over here to the apex. Now, that'll give you not 270, 436. So, 45, 135. 135 over 2. Okay, this is 67. No, what have I done wrong? Not the base. The base, apologies. The base is not 15. The base is 16. I counted wrong. Now, if the base is 16, then 9 times 16 is 144. Okay. 144. And 144 divided by 2 is 72. 72 cubic centimeters. Oh, not cubic, square centimeters. Now, what we found is actually different from what the question said, isn't it? We realize, oh, I thought the question said 18 square centimeters. Why is it 72 square centimeters? It must mean each of these squares are not 1 cubic centimeters, 1 squared centimeters big. What's the ratio? Well, whatever number we find, the actual area is 4 times less. Can you guys see that? 72 is actually 4 times bigger than 18. Or another way to think of it is 18 centimeters is 4 times less than 72. Okay? So meaning that the actual area is 4 times less of what we calculated. Okay? And once we find that ratio, and I'm going to put that in this red box because this is so important. Then we come back to our 22.5. Let's have a look. In that case, if we apply that rule, 22.5, our actual area is 4 times less. Let's have a look. What's that? 5, 20, and then we put the decimal there, and we can just put 25. So 6, 24, 1. How many times does 4 go into 10? 2 times, 8, 2, and then 5. So actually, our area is 4 times less, which is 5.625. And there we go. We found our answer, which is E. Okay? So yes, there was a lot to think about in this question. Mainly, number 1, how to find the area of triangle ACD. And number 2, checking whether or not the question states the units. Okay? And whether or not our units are actually right. So, those 2 things always to look out for in these sorts of questions. Let's move on. Question number 6. The number of hours that were left in a day was 1/5 the number of hours already passed. How many hours were left in the day? I like to draw this little diagram. Imagine it's a sun, okay? Representing the number of hours in a day with light. So, it says 1/5 of the number of hours already passed is how much was left. So if we draw that, let's say we've got 1 part to 5. We've got 1 part to 5. Meaning that, let's check. The number of hours that were left, imagine that was 1/5 of the numbers already passed, which is 5. Okay, so we can check that this is right, this ratio. By ratio, I mean some sort of proportion between 2 values. So 1 part to 5 parts is what we're looking at. Okay? So if 1 part is how much is left, and the 5 parts is how much has passed, okay? That's our ratio right there. Then, what other fact do we know? We know that regardless of how many parts on one side, how many parts on the other, those parts added together must equal to 24. Why 24? Why is it this number? Well, there's 24 hours in a day, meaning that it doesn't matter how many parts we have on one side or the other. Those parts added together has to be equal to the total amount of hours relevant. Okay, so 1 plus 5 parts is 24 hours. So we can actually find out how much 1 part is. It's 24 divided by 6, which is 4 hours. So once we find that out, that's quickly finding out the answer. So since 1 part is 4 hours, there is 4 hours left in the day, which is C. Okay. Let's have a look at the next question. If the length of a side of a certain square is increased by 3 meters and the area is increased by 39 square meters, if the length of the side of this bigger square is then increased by 6, how many square meters bigger than the original square is this new square? Okay. Give yourself some time to let this question actually sink in. And once you've gotten the idea of what we need to do, then the first question you should get in your mind is, well, how much was the length of that first square? And the answer is, well, we don't know. So, in these sorts of questions, when we don't know, don't second guess. Straight away, just implement your guess and check, or trial and error, whatever you call it. How do we guess and check though? Well, or specifically, what do we need to guess and check for? Well, if we know that some sort of side is increased by 3, then the area is increased by 39, okay? But then this length of the side is now still a square. What does that mean? If some small square, right, then becomes a bigger square by adding 3, add 3 meters side, right? Then it must mean that whatever this area is, this area must be a square number. Still a square number. So, here we just try our trial and error. Imagine this is 1. And I'm going to write this trial and error. Okay. Imagine the first side was 1 meter. Okay? We increased it. That means the area was, we increased it by how much? Increased it by 3. So what does that mean? Our area, that's 4 meter. So 4 squared is 16. But that's not what we want, right? So some area difference has to be equal to 39. So we know definitely then 1 squared, since that's 1 meter squared, right? Plus 39 is not, that looks like T, doesn't it? Is not a square number, okay? So, cannot be the area of the new square. Alright? So, since it cannot be the area of the new square, let's move on to the next number. 2. Let's try 2. 2 squared, imagine the first square was 2. Then our area is 4. 4 square meters. Now, if we add 39 to that, what do we get? We get 43. So, that's not it. Then we cross it out. Let's go to the next one. Let's try 3. 3 squared is 9. 9 plus 39 is 48. So, nope, that doesn't work. Next. Let's try 4. 4 times 4 squared equals to 16. 16 plus 39 is 55, which is still not a square number, so we get rid of that. Next, let's try 5. 5 squared equals to 25. 25 plus 39 is 64. Oh, we found our square number. So, immediately we know that 5 is our initial square length. So, 5 it is. 5 square meters. Then, the next size is 8 square meters, right? And then, what does the next question say? If the length is then increased by 6, right? Then it must mean that the next side length is 14. Not 14 square meters. I shouldn't write square meters. It should be 8 meters. Okay, 14 meters. Then this area is 14 squared, which equals to 196 meters squared. Now, what's the question asking for? How many squares meters is then the original square is this new square? New square is 196. So 196 minus, how much was the old square? The original one? 5. 25. The area was 25. So the answer is 171. Okay, the area of the smaller was 25 because 5 by 5 is 25. So the answer is 171 squared meters, which is A. Hopefully that makes sense. All right, so we've come to the end, but let's just look at the main points summarized. So number 1, probability is what? It is the object of interest over the total number, I'm going to denote that by no dot, of objects in the first place. Okay, that was from question number 1. Question number, dot point number 2, plan always before proceeding. Okay, plan before working something out. And why do I say that? Well, because look at question 3. Look at how many steps we had to go in order to solve this. Number 1, we realized that we couldn't find ACD straight away, so we had to realize that in order to find the answer, we need to subtract 2 triangles in order to find the area of ACD. Okay, so always plan before proceeding. I can't stress how important this is. And dot point number 3, when in doubt, use trial and error method. And I'm sure you guys can guess it. It was from question number 10. Use trial and error, and don't be scared to do so, because you'll find that more often than not, this is the easiest way to solve these sort of questions without algebra. Okay, and you guys don't need algebra too much right now. So if it's a lot more difficult than what you know, then just use trial and error. The right answer is still a right answer. Okay.